Okay, students, so let's get started with today's paper. Today we have to do May-June 2022, paper 2, variant 2. So let's start with this. Figure 1.1 shows a water skier pulled horizontally across the water surface. Okay, so this is a water skier pulled horizontally across the water surface. Perfect. The mass of the water skier is 60 kg. Perfect. The gravitational field strength is this. We have to calculate the weight of the water skier. Weight is equals to mg. Mass is 60. Gravitational field strength is 10. Weight comes out to be 600 Newton. Perfect. Mass and weight have different units. Perfect. Mass and weight have different units. State two other differences between mass and weight. You have to state two other differences between mass and weight. Weight is a vector quantity, whereas mass is a scalar quantity. What is mass? Mass is the amount of matter in a substance, and weight is a force due to the gravitational field strength. So you can write it here. First difference can be that weight is a vector quantity. However, mass is a scalar quantity. However, mass is a scalar quantity. Perfect. Second difference क्या लिखोगे बेटा? You will say that mass. Second difference you will say that mass is the amount of matter in a substance. Matter in a substance. And what is weight? What is weight? Weight is the force due to the gravitational field strength. Weight is the force due to gravitational field strength. Perfect. Nothing complicated here. Let's further move ahead. Let's move on to the next question. A boat pulls the water skier to the right with a horizontal force of 50 Newton. Perfect. The water skier travels at constant speed. Perfect. Explain in terms of the horizontal forces acting why the speed is constant. Beta, when is the speed constant? When the resultant force is zero. When will the resultant force be zero? When will the resultant force be zero, beta? Right side पे the boat is applying a 50 Newton की force. So you can say that we have a frictional force or a drag force or resistive force of 50 Newton towards the left hand side as well. This will cause the resultant force to be zero. First of all, you will have to tell when is speed constant. When is speed constant? You will say the speed is constant because resultant force is zero. Because resultant force is zero. Next up, you will say the 50 Newton force on the right hand side, the 50 Newton force on the right is balanced by resistive forces of 50 Newton on the left. Resistive forces of 50 Newton on the left. Perfect. Let's further move ahead. The horizontal force acting on the right increases from 50 to 70 Newton. The size of other forces are unchanged. Perfect. बेटा अब आपकी जो राइट पे फोर्स लग रही है वो 50 से क्या हो गई है? वो 50 से हो गई है 70. Perfect. You have to calculate the acceleration of the water skier. You have to calculate the acceleration of the water skier. First of all, what are you going to do here? You are going to calculate the resultant force. How are you going to calculate the resultant force? Right force minus the left force, 70 minus 50. The resultant force comes out to be 20 Newton. Perfect. What is the mass of the water skier? 60 kg. Perfect. You will say, resultant force that is equals to 20 Newton is equals to what? Mass into acceleration is equals to 20. Mass is what? 60 into acceleration, that is equals to 20. Acceleration is equals to 20 divided by 60. That comes out to be 0.33 ms minus 2. Perfect. So 0.33 ms minus 2 is your acceleration. Yeah, perfect. Let's further move ahead. आगे बढ़ते हैं बेटा नेक्स्ट सवाल पे। फिगर 2.1 shows a long cardboard tube sealed at both ends perfect, which contains many small pieces of metal. Okay, so there are many small pieces of metal. Perfect. The tube is turned vertically so that the pieces of metal fall from one end to the other. बेटा ये pieces of metal one end से दूसरी end की तरफ आ रहे हैं as you are turning the tube vertically. Perfect. The temperature of the pieces increases as a result of the fall. Perfect. Temperature increase कर रहा है बेटा. During the fall, gravitational potential energy of the metal pieces is transferred to other forms of energy. But gravitational potential energy is getting converted into other forms of energy. So, gravitational potential energy gets converted into other forms. Perfect. State two forms of energy to which gravitational potential energy is transferred. First of all, can you see the temperature of the pieces is increasing? Beta, agar temperature of the pieces is increasing, that means gravitational potential energy is getting converted into what? Thermal energy. Secondly, can you realize initially these pieces were at rest? As you turn the tube vertically, they gain some amount of velocity. So basically, what is happening? Gravitational potential energy is also getting converted into kinetic energy. Kinetic energy and thermal energies are the two energies in which gravitational potential energy get converted. Perfect. The average fall, the pieces fall an average distance of 1.2 meter during one turn. The total mass of the metal is 150 grams. Perfect. Calculate the loss in gravitational potential energy of the pieces as they fall once. How will you calculate that? Gravitational potential energy is equals to mgh. What is the mass? 150, but we will write it in kilograms. So this is 0.15. G is 10. What is the height? 1.2. What does the loss in gravitational potential energy comes out to be? The loss in gravitational potential energy is 1.8 joules. Perfect. Simple. Let's further move ahead. A student turns the tube quickly after the small pieces have fallen from one end to the other 80 times. Wow. So you are turning the tube 80 times. Perfect. The temperature has increased by 7 degrees centigrade. Calculate the specific heat capacity, that is C of the metal. बेटा आपने C निकालनी है. आप क्या करोगे? First of all, let's calculate the total energy. Total energy due to 80 turns या कह लो due to 80 rotations. बेटा what will be the total energy due to 80 rotations? एक रोटेशन या एक टर्न की वजह से एनर्जी क्या आ रही है? 1.8. What will be the total energy due to 80 rotations? 80 into 1.8. Perfect. What will your answer come out to be? 80 into 1.8. This comes out to be what? 144. The total energy due to 80 rotation comes out to be 144 joules. So this is the energy that is being transferred to the small metal pieces. Perfect. This is the energy that is being transferred to the small metal pieces. Which formula will you apply further? Q is equals to mc delta T. What is the energy? 144. What is the mass? 0.15. You have to calculate a specific heat capacity. What is change in temperature? 7. What does C comes out to be? 144 divided by 0.15 into 7. What does a specific heat capacity comes out to be? A specific heat capacity is equals to 140 joules per kg degree centigrade. Simple. The student repeats the experiment, turning the tube more slowly. Perfect. Suggest why a different temperature increase is obtained. बेटा अब जो स्टूडेंट है वो स्लोली क्या कर रहा है? ट्यूब को रोटेट कर रहा है. Why a different temperature increase is observed? Because more time is available for energy to be lost. बेटा जितना आप ज्यादा स्लो रोटेट करोगे ट्यूब को उतना ज्यादा टाइम अवेलेबल होगा फॉर एनर्जी लॉस. सो यू कैन से more time is available for energy loss. More time is available for energy loss. Perfect. More time is available for energy loss. Let's further move ahead. Figure 3.1 shows a syringe mounted vertically in a block of wood, perfect, and sealed at one end. Beta, this is a syringe that is mounted on a block of wood and it is sealed at one end. A plunger is free to move inside the syringe. Perfect. एक plunger है that is free to move inside the syringe. Perfect. There is trapped air in the syringe. बेटा यहाँ पे trapped air है inside the syringe. Perfect. Okay. The air inside the syringe exerts a pressure on the walls of the syringe. Define the term pressure. Okay, what is pressure? Pressure can be defined as force per unit area. Force per unit area is your pressure. Perfect. Nothing complicated. आगे बढ़ते हैं बेटा. Explain how the air molecules in the cylinder of the syringe exert a pressure. Beta, how do the air molecules present in these trapped air exert a pressure? You will say what? The air molecules move at random and hit the walls of the piston. बेटा हमने बताना है ये एयर मॉलिक्यूल्स किस तरह प्रेशर जनरेट कर रहे हैं. We have to tell how these air molecules are generating a pressure. क्या कहोगे आप? You will say the air molecules are moving at random and they hit the walls of the piston. The air molecules are moving at random and they hit the walls of the piston. As they hit the walls of the piston, they exert a force. This force per unit area gives rise to pressure. So you can write it here. You can say the air molecules move randomly or move in a random manner or move randomly and collide with the walls of the container or with the walls of the piston walls with the walls of the piston. This exerts a force on the walls of the piston, a force on the walls of the piston, on the walls of the piston. The force per unit area, the force per unit area gives rise to pressure, gives rise to pressure. Simple, nothing complicated here. Let's further move ahead. आगे बढ़ते हैं बेटा. A 10 Newton weight is placed on top of the plunger. The plunger moves down slowly so that the temperature of the air inside the syringe does not change. Okay. So the temperature of the air inside the syringe does not change. Perfect. बेटा हैव आई टोल्ड यू दैट जब टेम्परेचर कांस्टेंट रहेगा या चेंज नहीं होगा विच लॉ विल बी अप्लाइड? बॉयल्स लॉ. Boyle's law will be applied when temperature is constant. Perfect. Before the weight is placed on the top of the plunger, the pressure of the air inside the syringe is this. This is the initial pressure. And the volume of the air inside the syringe is this. This is the initial volume. Perfect. The cross sectional area of the plunger is this. Perfect. Calculate the pressure of the air in the syringe after the plunger stops moving. Okay. So you have to calculate the pressure of the air in the syringe after the plunger stops moving. बेटा आप क्या प्लेस कर रहे हो? आप एक 10 न्यूटन का वेट प्लेस कर रहे हो ऑन टॉप ऑफ द प्लंजर लाइक दिस यू आर प्लेसिंग अ 10 न्यूटन का वेट. परफेक्ट. as you place a 10 newton ka weight on the top of the plunger, this will exert some extra pressure. How can you calculate the pressure exerted by this 10 newton ka weight? How can you calculate the pressure exerted by this 10 newton ka weight? Very, very easy. Pressure is equals to force over area. The extra force is 10 newton. What is the cross sectional area? 1.2 into 10 raised to the power of minus 4. So 10 divided by 1.2 into 10 raised to the power of minus 4. What is the extra pressure that is being applied due to the weight? 1.2 into 10 raised to the power of minus 4. This comes out to be 83333 pascals. Perfect. This is the extra pressure that is being exerted due to what? Due to the weight. Perfect. बेटा ये एक्स्ट्रा प्रेशर है ड्यू टू द वेट. That is 83333 pascals. What was the initial pressure? 1 into 10 raised to the power of 5. This is the extra pressure due to the weight plus the initial pressure, that is 1 into 10 raised to the power of 5. This will give you the final pressure. This will give you the final pressure. This comes out to be plus 1 into 10 raised to the power of 5. If I do that, this will be equal to 1.83. 1.83 into 10 raised to the power of 5 pascals is your final pressure. Perfect. Calculate the volume of the air inside the syringe after the plunger stops moving. You have to calculate V2. Beta, how are you going to calculate V2? Very, very easy. Do you remember that Boyle's law can be written like this? P1 V1 is equals to P2 V2. बेटा इनिशियल प्रेशर क्या है 1 into 10 raised to the power of 5. इनिशियल वॉल्यूम क्या है 50. फाइनल प्रेशर P2 क्या है 1.83 into 10 raised to the power of 5. You have to calculate the final volume. Just plug and play. 1 into 10 raised to the power of 5 into the volume, that is 50, is equals to the final pressure, that is 1.83 into 10 raised to the power of 5 into volume V2. Can you calculate the volume V2? Yes, easy. The volume V2 comes out to be 28 cm cube. The volume V2 comes out to be 28 cm cube. Perfect. आगे बढ़ते हैं बेटा. Figure 4.1 shows a ray of white light incident on a glass prism. Perfect. So this is a ray of white light that is incident on a glass prism. Refraction causes the white light to separate into different colors. Okay, determine the term angle of refraction. Beta, what is angle of refraction? Angle of refraction is the angle between the normal and the refracted ray. You can write it here. Angle of refraction is the angle is the angle between is the angle between the normal and the refracted ray, between the normal and the refracted ray. Perfect. Angle of refraction is the angle between the normal and the refracted ray. Perfect. आगे बढ़ते. The angle of incident of white light as it enters the prism is 40 degree. Angle of refraction is 25 degree. Calculate the refractive index of red light. बेटा किस तरह निकालेंगे refractive index? Do you remember refractive index is equals to what? Sin I over sin R. Beta refractive index is equals to what? Sin I over sin R. Okay, sin I over sin R is your refractive index. Perfect. Sin I over sin R is your refractive index. I क्या है 40 degree, R क्या है 25 degree. Refractive index will become what? Sin 40 divided by sin of 25. This gives you an answer of what? बेटा ये calculator में put करो. The refractive index comes out to be 1.5. Perfect. Use figure 4.1. Okay, you have to use figure 4.1. State and explain how the refractive index for red light differs from the refractive index of violet light. Now remember, बेटा जिस लाइट का या जिस सब्सटेंस का रिफ्रैक्टिव इंडेक्स ज़्यादा होगा वो क्या करेगी, ज़्यादा बेंड करेगी. जिसका रिफ्रैक्टिव इंडेक्स कम होगा वो बेंड कम करेगी. Now from the diagram you can see what? From the diagram you can see violet is bending more. Hence violet will have a greater refractive index. You can write here. You can say you can say violet bends more. Violet bends more compared to what? Compared to red light. Hence you will say the refractive index of violet is greater than the refractive index of red light. Is greater than the refractive index of red light. Refractive index of red light. Simple सवाल बेटा. आगे पढ़ते. The source of white light used in figure 4.1 produces other type of electromagnetic radiation as well as visible light. Perfect. So you have some other types of electromagnetic radiation also being produced. State the name of the invisible radiation found at P and the invisible radiation found at Q. Okay. You have to state the name of the invisible radiation found at P and the invisible radiation found at Q. If you analyze the radiation that will be found at P will have a greater wavelength. बेटा जो P पे radiation होगी that will have a greater wavelength than what? Greater wavelength than red. Why? बेटा P पे जो radiation होगी उसकी wavelength क्या होगी? Greater wavelength than red. Why? Because it is bending less than red. बेटा अगर कोई चीज लेस बेंड कर रही है तो उसकी वेवलेंथ लार्जर होगी. So, what is a component of electromagnetic spectrum that has a larger wavelength than red? Maybe infrared radiation here. Infrared radiation at P. Perfect. And if you see point Q, at point Q, you will have a lower wavelength than violet. Perfect. Why? Because you are bending more than violet. बेटा अगर आप violet से ज़्यादा bend कर रहे हो, that means you will have a lower wavelength than violet. What is a possible example of this? Ultraviolet. Simple. What is a possible example of this? Ultraviolet. You can write it here. You can say point P is infrared and point Q is what? Ultraviolet. Simple. Nothing complicated here. You can write ultraviolet radiations of, oh, sorry, infrared radiation and ultraviolet radiations if you want to be an A star student. Let's further move ahead. A student connects a battery, thermistor X, resistor Y in parallel as shown in figure 5.1. Perfect. So you have a battery, you have a thermistor, you have a resistor Y. Perfect. The electromotive force of the battery is E. Perfect. The current in X is I. Perfect. The resistance of Y is greater than the resistance of X. Perfect. So the resistance of Y is greater than the resistance of X. Perfect. Let's further move ahead. Take two boxes, one to show the correct statement about the potential difference across Y and the other to show the correct statement about the current in Y. Perfect. Beta, what will be the potential difference across Y? What will be the potential difference across Y? Can you realize this is a parallel circuit? Can you realize that this is a parallel circuit, beta? अगर parallel circuit है, that means what? Voltage will remain constant. This will be E as well. This will be E as well. Both the branches will be receiving a voltage of E. Hence, the resistor Y receives a voltage of what? Equal to E. Perfect. Now, can you realize that the current in thermistor X is I? But we know that the resistance of Y is greater than the resistance of X. We know that the resistance of Y is greater than the resistance of X. Perfect. But if this Y has a greater resistance, then what will happen? The current in Y will be less than the current in X. So current in Y is less than I. This is your tick mark box. Let's further move ahead. The student connects the thermistor X in series with the resistor and a battery of EMF 6 volts. Okay, so now both of them are connected in series. Perfect. In this circuit at room temperature, the resistance of the thermistor is 600 ohms. Perfect. So the resistance of the thermistor is 600 ohms. Okay. And the current in the thermistor is 0.002. Perfect. So the current here is 0.002. Perfect. Calculate the power produced in the thermistor. How will we calculate the power produced in the thermistor? What is the formula of power? Power is equals to I square R, current square into R. What is current? 0.002 square into the resistance, that is 600. Can you calculate this answer? 002 squared into 600. This comes out to be what? The power comes out to be 2.4 into 10 raised to the power of minus 3 volts. Perfect. You also have to calculate the resistance of Y. बेटा आपने resistance of Y भी calculate करना है. How will you do that? Very, very easy. First of all, let's do one thing. Let's do one thing. Let's calculate the voltage across X. Better, let's calculate the voltage across X. What is the voltage across X? Current, that is 0.02 into 600. What will be the voltage across X? 0.02 into 600. This comes out to be 1.2. The voltage across X is 1.2. What will be the voltage across Y? 6 minus 1.2, that is 4.8 volts. Perfect. What will be the current across Y? 0.002 ampere. Perfect. This is the voltage. This is the current. Across resistor Y. Can you calculate the resistance of resistor Y? Yeah. Voltage divided by current. बेटा वोल्टेज अक्रॉस रेजिस्टर वाई क्या आ रही है 4.8 डिवाइडेड बाय करंट दैट इज 0.002 परफेक्ट 4.8 divided by 0.002. This comes out to be 2400 ohms. Simple. The resistance of Y comes out to be 2400 ohms. Simple. Let's keep it here. Oh, sorry. I think I have. Okay, so this is not movable. I think this is not movable. Yeah, perfect. We can move it. The resistance comes out to be 2400 ohms. Perfect. Let's further move ahead. Let's see the next one. The thermistor is cooled. Perfect. So basically, the temperature of the thermistor is decreasing. The thermistor is cooled. That means the temperature of the thermistor is decreasing. That means the resistance will increase. Perfect. Explain why this causes the potential difference across Y to decrease. Let's see what is Y. Okay, why is this? Perfect. If the thermistor is cooled, okay, now I will have to minimize, or what I can do is I can take this working to the previous part. यहाँ पे रख देते हैं working, ठीक है? Now the thermistor is cooled. If the thermistor is cooled, the resistance of thermistor will increase. Let's say this will go from 600 to 700 ohms. If the resistance of thermistor increases, the voltage across thermistor will increase. If the voltage across thermistor increases, the voltage across this resistor Y must decrease. If the voltage across the thermistor increases, beta, the voltage across Y should decrease. Now you will say, sir, why? Why is that scenario? Why should I believe you? Very, very easy to understand this if you can pay attention for the next 2 minutes. बेटा देखो थोड़ी सी बात को समझो थोड़ी सी बात को समझो Can you realize we have a 6 volts battery? Yeah. Initially, let's say X was receiving 1.2 volts, Y was receiving 4.8 volts. When the resistance increases, this goes to 700 ohms. बेटा X की voltage increase हो जाएगी, let's say 2 volts हो गई. If the voltage across X goes to 2 volts, can you realize 2 plus 4.8 will be 6.8? This is not possible. This will become greater than the EMF of the battery. So this voltage of Y has to decrease to, let's say, 4 volts to cause the EMF of the battery to become 6 again. So beta ye likh lo yahan pe. You will say as thermistor cools, what will happen? The resistance of Y or thermistor increases. The resistance of thermistor increases. Perfect. Hence, the voltage across thermistor increases. Perfect. As the voltage across thermistor increases, the voltage across X decreases. Simple. As the voltage across thermistor increases, the voltage across X will decrease. I guess it is X या Y. Y था या X था? Let me see. Yeah, sorry. The voltage across Y will decrease. Sorry, my bad. The voltage across Y will decrease. Well, chalo, let's move ahead. Now let's see this. Figure 6.1 shows part of a toy which contains two ring-shaped permanent magnets, a plastic rod through the center of both magnets. Perfect. So we have a plastic rod through the center of both magnets. We have these two magnets. Perfect. The top magnet can move up and down freely around the plastic rod. Perfect. The magnetic poles on the bottom magnet are shown in figure 6.1. Perfect. So the magnetic poles on the bottom magnet are shown. The up layer is north, the down layer is south. Perfect. The top magnet floats in the air. Perfect. Above the bottom magnet. ठीक है. बेटा टॉप मैग्नेट क्या कर रहा है? इट इज फ्लोटिंग इन द एयर अबव द बॉटम मैग्नेट. Perfect. On figure 6.1, mark the poles on the top magnet and explain why it floats in the air above the bottom magnet. बेटा आपने टॉप मैग्नेट पे पोल्स बनाने हैं एंड यू हैव टू टेल व्हाई डज इट फ्लोट ओवर द बॉटम मैग्नेट. यू हैव टू मेक पोल्स ऑन द टॉप मैग्नेट एंड यू हैव टू टेल व्हाई डज द टॉप मैग्नेट फ्लोट्स अबव द बॉटम मैग्नेट. बेटा एक ही कंडीशन में ये टॉप मैग्नेट बॉटम मैग्नेट के ऊपर फ्लोट कर सकता है. इफ दीज पोल्स आर लाइक पोल्स, ये नॉर्थ हो, ये सारा नीचे का हिस्सा नॉर्थ हो, देन नॉर्थ नॉर्थ रिपेल एंड द टॉप मैग्नेट फ्लोट्स अबव द बॉटम मैग्नेट. यू कैन से दैट. You can say that top magnet has north pole at the bottom side. और top side पे क्या हो जाएगा भाई? Top side पे for the top magnet we will have south pole. Like poles repel, hence the top magnet floats in air. You can write it here. The bottom part, the bottom of the top magnet of the top magnet is what? Is north pole. Perfect. And the top of the top magnet, the top of the top magnet, the top of the top magnet is south pole. Simple. What will be your last line? You will say, since like poles repel, hence the top magnet floats above the bottom magnet. You will say, since like poles repel, like poles repel, bottom magnet, or sorry, top magnet floats above the bottom magnet. Top magnet floats above bottom magnet. Simple. Top magnet floats above the bottom magnet. Simple as that, nothing complicated. The top magnet is replaced with a ring made of iron. Explain why the iron ring sticks to the bottom magnet. बेटा बहुत easy सवाल है. The top magnet is now replaced with the iron ring. Now, what do you remember about iron? Iron is a temporary magnet. Iron always attracts. Iron is a temporary magnet. Iron always attracts. So you will say, iron is a temporary magnet. Hence. बेटा बॉटम हाफ में क्या डेवलप हो जाएगा? इफ दिस इज अ आयरन रिंग, बॉटम हाफ में बेटा क्या डेवलप हो जाएगा? बॉटम हाफ में साउथ पोल्स डेवलप हो जाएंगे. Unlike poles attract and the iron rod or the iron ring gets stick to the bottom magnet. You will say iron is a temporary magnet, is a temporary magnet. Hence, the bottom of iron, the bottom of iron ring becomes south pole, becomes south pole. Since unlike poles attract, since unlike poles attract, what will happen? Since unlike poles attract, what will happen? Iron ring sticks to the bottom magnet. Iron ring sticks to the bottom magnet. Sticks to the bottom magnet. Perfect. Let's further move ahead. Iron ring sticks to the bottom magnet. आगे बढ़ते हैं. A wire carrying a current passes at right angles through a piece of paper. Perfect. Figure 6.2 shows a cross and a circle where the current in the wire passes into the plane. So the current is going into the plane. Perfect. On figure 6.2, sketch three magnetic field lines to show the magnetic field pattern around the wire. Show the direction of field on your sketch. Perfect. So beta current is going into the page. You have to draw the magnetic field lines. Current is going into the page. You have to draw magnetic field lines. How will you draw it? Always remember, whenever current is going into the page, you draw what? You draw clockwise field lines. बेटा जब भी करंट into the पेज जा रहा होता है, you draw clockwise field lines. And what is one thing that you need to remember? What is one thing that you need to remember? What is one thing that you need to remember? The distance between the clockwise field lines keeps on increasing. The distance between the clockwise field lines keeps on increasing. Like this. The distance between the clockwise field lines keeps on increasing. Let's put this in the box correctly like this. Maybe like this. Let's adjust it. The distance between the field lines keep increasing. I think the middle one is quite big. Let's make it a bit smaller. इसको थोड़ा सा छोटा कर देते हैं. Yep. The distance between the field lines keeps on increasing. Like this. Like this. Perfect. You have to draw three magnetic field lines. You have drawn it. Make sure all of them are pointing in the clockwise direction. Perfect. Let's further move ahead. अब इस सवाल पे आ जाओ. Figure 7.1 shows the speed time graph for a car traveling along a straight horizontal road. Perfect. So this is the speed time graph for a car traveling along the straight horizontal road. Perfect. You have to describe the motion of the car. It is a three marker question. Can you see the car is performing three unique motions? First of all, it is accelerating, then it is moving at a constant speed, then it is decelerating. So you have to define all three motions. Let's define it. You will say from time t is equals to 0 till time t is equals to 10 seconds. You will say from time t is equals to 0 till 10 seconds, the car is accelerating. The car is accelerating with an acceleration of what? With an acceleration of. Now you can calculate the acceleration here. This point is 0, 0, and this point will be what? 10, comma 16. Perfect. What will the gradient be equal to here? Y2, that is 16, minus y1 divided by x2, that is 10 minus 0. This comes out to be 8 over 5, that is equals to 1.6 ms minus 2. Perfect. So from time t is equals to 0 till 10 seconds, the car is accelerating with an acceleration of 1.6 ms minus 2. Perfect. What will be your second point? You will say from time t is equals to 10 seconds till 20 seconds, the car is traveling at a constant speed of 16. Let's write it. You will say from time t is equals to 10 seconds till 20 seconds, the car travels at a constant speed of 16 ms minus 1. Perfect. And for the last half, from time t is equals to 20 till 24, the car is decelerating. Okay, let's say this point is 20 and 16. This point is 24, comma 0. What will be the gradient here? 0 minus 16 divided by 24 minus 20, that is 4. This comes out to be negative 4. So, basically, in the last half, from time t is equals to 20 till 24 seconds, your car is decelerating with the value of 4 ms minus 2. You can write it here. From time t is equals to 20 seconds till 24 seconds, the car is decelerating at a value of 4 ms minus 2. Perfect. Use figure 7.1 to calculate the distance traveled by the car during the 24 seconds of its motion. Show your work. Okay. So we have to calculate the distance traveled by the car during the 24 second of its motion. I think I will need to erase some points here. How can you calculate the distance from a speed time graph? The area under the speed time graph is equals to your distance. The area under a speed time graph is equals to your distance. Now this is what? This is a trapezium. This is a trapezium. How do we calculate the area of trapezium? The area of trapezium is 1 upon 2 into sum of parallel sides. Sum of parallel sides multiplied by height. Perfect. So how will we calculate this area? 1 upon 2 into what are the parallel sides? One parallel side is this 24. The other parallel side is this from 10 till 20. Perfect. So you can say 24 plus 10. Perfect. What is the height? The height is 16. This becomes 1. This becomes 8. Perfect. This will be equal to what? 34 into 8. बेटा आपका एरिया ऑफ ट्रेपीजियम क्या आ जाएगा 34 into 8. This gives you a value of 272 meters. This gives you a value of 272 meters. The distance traveled by the car during 24 seconds is 272 meters. Perfect. Nothing complicated here. 272 meters is your answer. आगे बढ़ते हैं बेटा. You have to calculate the average speed of the car during the motion. Now, what is the formula of average speed? Average speed is equals to the total distance over total time. Perfect. Total distance over total time is your average speed. बेटा total distance क्या है 272. What is the total time? 24 seconds. Divide कर दो. 272 divided by 24. This comes out to be 11.3. Average speed comes out to be 11.3 ms minus 1. Perfect. आगे बढ़ते हैं बेटा. A second car travels at a steady speed. It travels the same distance as the first car in the 24 seconds of the journey. On figure 7.1, draw the speed time graph for the second car. अच्छा बेटा सेकंड कार क्या कर रही है स्टेडी स्पीड पे ट्रैवल कर रही है या कांस्टेंट स्पीड पे ट्रैवल कर रही है फॉर द 24 seconds and it is still covering the same distance. Beta, if you are covering the same distance and you are still traveling 24 seconds, तो इसका मतलब क्या है इनडायरेक्टली? इसका मतलब क्या है बेटा इनडायरेक्टली? इनडायरेक्टली एग्जामिनर आपको ये कहना चाह रहा है दैट वी हैव अ सेकंड कार that is traveling at the average speed for 24 seconds. Beta, we have a second car that is traveling at the average speed for 24 seconds. It will also cover the same distance. Average speed क्या है? 11.3. So where will 11.3 be? 11.3 beta कहाँ होगी? Now I will need to shift this. Let's zoom out. I will need to shift this. Yeah, you can place it here. Perfect. So beta, how will you mark 11.3 की speed? First of all, let's see the axes. Oh, let's see the axes. Can you realize this is 8? Can you realize this is 12? 8 से लेकर 12 पे जा रहे हो कितने यूनिट्स कवर कर रहे हो 4. How many boxes are you covering? If you are covering 4 units, how many boxes are you covering? 5 boxes. Perfect. One box is equals to how many units? One box is equals to 0.8 units. Perfect. So this is 8.8. This is 9.6. This is 10.4. This will be 11.2. Yeah, somewhere here. So your line will be, okay, if I do the scale wala part again, if you didn't understand it, beta 8 से आप 12 जा रहे हो. You are covering 4 units in how many small boxes? In 5 small boxes. Perfect. तो बेटा एक बॉक्स कितने यूनिट के इक्वल होगा 0.8. Perfect. This is 8.8. This is 9.6. This will be 10.4. This will be 11.2. So the last box is equals to 11.2. This thing. You have to mark a speed of what? 11.2. 3. So maybe just a little above this, just a little above this, इस तरह से कुछ. Make sure you have a sharp pencil and just a little above it, like this. हाँ, इस तरह से. This will be your graph. Perfect. आगे बढ़ते हैं. Let's move ahead. So let's zoom out. Let's see this. What is written? Okay. The thinking distance is the distance traveled by the car between the time that a hazard is seen and the time that brakes are applied. Perfect. Thinking distance क्या होता है बेटा? Thinking distance is the distance traveled by a car between the time that a hazard is seen and the time that the brakes are applied. Perfect. The braking distance is the distance traveled by the car while the car slows down to rest. Perfect. Table 7.1 shows the thinking and the braking distance for an alert driver when the car travels at different speeds. ठीक है बेटा. थिंकिंग डिस्टेंस का चार्ट भी गिवन है, ब्रेकिंग डिस्टेंस का चार्ट भी गिवन है. परफेक्ट. कंप्लीट फिगर 7.1. परफेक्ट. कैन यू रियलाइज जब आप 20 की स्पीड पे जा रहे थे, थिंकिंग डिस्टेंस वाज 9. When you were traveling at a speed of 40, the thinking distance doubled. As the speed doubled, thinking distance doubled. What will happen if the speed triples? The thinking distance will triple as well. This will become 27. Perfect. The time it takes for the driver to react to the hazard is constant at different speed. Explain how the table shows this. बेटा हमने ये बताना है कि reaction time of the driver is remaining constant at different speeds. How are we going to tell that? Very, very, very easy. If you realize what is thinking distance equal to, बेटा thinking distance जो आप निकाल रहे हो वो किसके equal है? The thinking distance is equals to what? Speed multiplied by the reaction time. Let's label it as TR. Can you realize that thinking distance और speed क्या है? Directly proportional. As the speed doubles, thinking distance double. As the speed goes triple, the thinking distance goes triple. That means thinking distance is directly proportional to speed. That means what? This reaction time or the time it takes for the driver to react will be constant or same. You can write this. Beta, you can write this. You can say since since thinking distance thinking distance is directly proportional to the speed, the reaction time must be constant. Since thinking distance is directly proportional to the speed, what will happen? Reaction time is constant. The time taken to react is constant. The time taken to react is constant. ठीक है. And if you are a A star student, you will further calculate the time and show the examiner. बेटा examiner को time calculate करके भी दिखा दो. How? Let's say, let's say you have a speed of 20. Okay, you have a speed of 20 kilometer per hour. You have a thinking distance of 9 meters. In kilometers, this will become 0.009 meters. सही है. 0.009 kilometers. Perfect. Can you calculate the time here? Yes. Very, very easy. Distance, that is 0.009 divided by 20, will be equal to your time. Why? Because time is equal to what? Distance over speed. Let's calculate this time. This will come out to be, बेटा ये टाइम इक्वल आ गया 0.009 डिवाइडेड बाय 20. 4.5 into 10 raised to the power of minus 4. 4.5 into 10 raised to the power of minus 4 hours. Since we have kept the time in hours. तो ये आप यहाँ पे कैलकुलेशन करके दिखा दो बेटा. और एक और वैल्यू के साथ भी ये करके दिखा दो. डू दिस विथ एन अदर वैल्यू सो दैट ओके सो डू दिस विथ एन अदर वैल्यू एज वेल टू शो दैट द टाइम इज रिमेनिंग कांस्टेंट. सो लेट्स टेक द स्पीड एज 40, थिंकिंग डिस्टेंस एज 18. सो बेटा यहाँ पे छोटी सी वर्किंग कर देते हैं. स्पीड एज 40 किलोमीटर पर आवर, डिस्टेंस एज 18 meters. This will be equal to 0.018 kilometer. Let's calculate the time again. Time is equals to distance over speed. Distance is 0.018 divided by speed, that is 40. This again comes out to be 4.5 into 10 raised to the power of minus 4 hours. So this time is remaining constant. Hence, we can say the reaction time or the time it takes for the driver to react remains constant. Perfect. State what happens to the thinking distance and the braking distance when the driver is tired. बेटा thinking distance क्या होगा when the driver is tired? Increase. Braking distance will remain constant. Simple. Nothing complicated here. Thinking distance बेटा increase हो जाएगा. Braking distance में no change. Perfect. Let's move on to the next question. Let's move on to the next question. Figure 8.1 shows a ripple tank and the crest of the water wave that is produced in it. Okay, so let's see this question. Figure 8.1 shows a ripple tank and the crest of the water wave that is produced in it. Perfect. So we have a ripple tank and the crest of the water wave that are produced in it are shown. Perfect. The frequency of water wave is 2 hertz and the amplitude is 3 millimeter. Calculate the number of crest produced in 1.5 seconds. बेटा सबसे पहला काम आपने क्या करना है? What do you have to do here? आपको फ्रीक्वेंसी गिवन है? यस सर गिवन है. फ्रीक्वेंसी से क्या आप टाइम पीरियड निकाल सकते हो? जी बिल्कुल निकाल सकते हो. टाइम पीरियड इज इक्वल टू 1 ओवर फ्रीक्वेंसी. 1 ओवर 2 इज इक्वल टू योर टाइम पीरियड दैट इज 0.5 सेकेंड्स. बेटा इसका मतलब ये है कि 0.5 सेकेंड्स में एक वेव कंप्लीट हो रही है. दिस इज 0.5 सेकेंड. 0.5 सेकेंड्स में एक वेव कंप्लीट हो रही है. एंड कैन यू हम्बली रियलाइज दैट 0.5 सेकेंड में ही आपके पास एक क्रेस्ट आ रहा है. बेटा if one crest is appearing in 0.5 seconds, how many crests will appear in 1.5 seconds? Cross multiplied, x comes out to be 3 crest. Simple as that. Number of crest in 1.5 seconds is 3. Perfect. The height of the wave is measured from the level of undisturbed surface of the water. The height of the wave at one point is 0. At one point is 0 at time t is equal to 0. Perfect. बेटा टाइम t इज इक्वल टू 0 पे आपकी हाइट क्या है? 0. परफेक्ट. और आपको पता है 0.5 सेकेंड्स में वन कंप्लीट वेव हो रही है. 0.5 सेकेंड इज द टाइम पीरियड फॉर वन कंप्लीट वेव. एट टाइम t इज इक्वल टू 0 योर डिस्प्लेसमेंट इज 0. परफेक्ट. हाउ विल यू ड्रॉ द ग्राफ? हाउ विल यू ड्रॉ द हाइट वर्सेस टाइम का ग्राफ यहाँ पे? वेरी वेरी इजी. बेटा अगर आप ऊपर जाओ तो आपको एम्पलीट्यूड गिवन है. यस सर, एम्पलीट्यूड इज 3 मिलीमीटर. बेटा अगर एम्पलीट्यूड 3 मिलीमीटर है दैट मीन्स दैट व्हेन वन क्वार्टर ऑफ द टाइम पीरियड इज कवर्ड. बेटा देखो आप टाइम पीरियड को क्वार्टर्स में डिवाइड कर लेते हो. ये फर्स्ट क्वार्टर है, ये सेकंड क्वार्टर है, ये थर्ड क्वार्टर है, ये फोर्थ क्वार्टर है. सो व्हेन द फर्स्ट क्वार्टर इज कवर्ड या व्हेन यू आर इन द मिडिल हियर एट दिस पॉइंट, यहाँ पे जब हो तब आपकी डिस्प्लेसमेंट क्या होगी बेटा? 3. एंड 3 इज समवेयर हियर. परफेक्ट. देन अगेन व्हेन यू आर एट 0.25 आपकी डिस्प्लेसमेंट 0. देन अगेन जब आप यहाँ पे मिडिल में हो दैट इज 0.375 लेट्स से, तो आपकी डिस्प्लेसमेंट क्या हो जाएगी बेटा? -3. दिस इज -3. परफेक्ट. देन यू विल हैव अ डिस्प्लेसमेंट ऑफ 0. परफेक्ट. ये आ गई आपकी फर्स्ट वेव लाइक दिस. फर्स्ट वेव लाइक दिस. परफेक्ट. दिस इज योर फर्स्ट वेव लाइक दिस. इस तरह से. नाउ let's do the same thing again for the consecutive points. At the middle here again आपका एम्पलीट्यूड क्या हो जाएगा बेटा? +3. फिर आपका एम्पलीट्यूड 0. फिर अगेन आपका एम्पलीट्यूड -3. फिर अगेन आपका एम्पलीट्यूड 0. वापस से वेव बना दो बेटा इस तरह की. somewhat like this. This is your wave. Perfect. बेटा अगेन यही काम करो. 0 then 3 then 0 then -3 then 0. अगेन वेव बना दो यहाँ पे. सिंपल. somewhat like this. This is your diagram. Perfect. बेटा हमने सिर्फ क्या चीज यहाँ पे विजुअलाइज की है. फर्स्ट ऑफ ऑल द एम्पलीट्यूड इज 3 mm. Then the time period is 0.5 second. I have taken two things and I have drawn this wave. Simple. Let's further move ahead. The frequency of the wave is increased. Perfect. So the frequency of the wave is increased. Describe how the apparatus shown in figure 8.1 is adjusted so that the frequency of the wave is increased. If you want to increase the frequency, what will you do? You will move the wooden bar more number of times. बेटा आप वुडन बार को क्या करोगे? मोर नंबर ऑफ टाइम्स अप एंड डाउन मूव करोगे. You will move the wooden bar up and down more often. You will move the wooden bar up and down more often. Move the wooden bar. Move the wooden bar. Wooden bar. Wooden bar up and down more often. More often per unit second. Per unit time. Perfect. आगे देखते हैं बेटा. State what happens to the speed and the wavelength of the wave as the frequency increases. Now here you have to remember beta speed क्या रहेगी? Unchanged. If I put in this formula v is equals to f lambda, the speed of the wave will remain unchanged. If the speed is remaining unchanged, frequency will be inversely proportional to lambda. If the frequency increases, the wavelength decreases. So you will write here this will remain unchanged and the wavelength decreases. Simple. Let's further move ahead. आगे बढ़ते हैं बेटा. The apparatus shown in figure 8.1 can be used to demonstrate refraction. Perfect. State the additional apparatus needed to demonstrate refraction. बेटा if you see here यहाँ पे ripple tank में कुछ चीजें missing है. You don't have a lamp here. You don't have a white paper here. You don't have a lamp here. You don't have a white paper here. Thirdly, you don't have a block. बेटा ब्लॉक क्यों चाहिए? Why do you need a block here? Why do you need a block here? So that you can create a shallow and a deep region. You need at least a block in one of the regions so that you can create a shallow and a deep region. So you can write here plastic block is missing. Plastic or a wooden block is missing. Wooden block is needed. Perfect. Let's further move ahead. Draw on figure 8.3 to show the refraction of water waves. Label a boundary where the refraction occurs. Now, beta, there is no need to complicate this question. There is no need to complicate this question. Please, please, please keep it simple. I am showing you a diagram जो आप यहाँ पे बना सकते हो. That will help you a ton. बेटा यहाँ पे आपको बहुत सारे डिफरेंट ओपिनियंस मिलेंगे कि इस तरह की बना लो डायग्राम, टिल्टेड बना लो, ये बना लो, वो बना लो. बट बिलीव मी अगर मेरी बात सुनते हो तो आपकी ज़िंदगी आसान हो जाएगी. ओके किस तरह ज़िंदगी आसान हो जाएगी? बेटा फर्स्ट ऑफ ऑल देखो एग्जामिनर मांग क्या रहा है आपसे. एग्जामिनर इज आस्किंग फॉर अ लेबल डायग्राम एंड द एग्जामिनर इज आस्किंग यू टू लेबल द बाउंड्री. परफेक्ट ठीक है. अच्छा एग्जामिनर कुछ भी स्पेसिफाई नहीं कर रहा आप डीप से शैलो जा रहे हो या शैलो से डीप जा रहे हो, तो हम यहाँ पे एग्जामिनर को बता देते हैं. लेट्स से वी आर गोइंग फ्रॉम डीप टू शैलो रीजन. हमने एग्जामिनर को बता दिया. परफेक्ट. दीज आर द इंपॉर्टेंट थिंग्स. Now you have to make a boundary as well. Let's make a boundary like this. Make a boundary like this. No need to tilt it. No need to tilt it and make your life unnecessarily complicated. Now, when you are going from a deep to shallow region, बेटा wavelength क्या होती है? कम. So आपने यही यहाँ पे दिखा देना है. What will you show here? You will show that initially the wavelength is larger, and as you pass the boundary, one second, as you pass the boundary the wavelength will decrease. As you go from deep to shallow your wavelength decreases. Oh, why is this overlapping? One second. आई विल ऑल्सो शो यू गाइज द मार्किंग स्कीम। बेटा ये वाली डायग्राम भी एक्सेप्टेबल है, प्लीज 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 डोंट ओवर कॉम्प्लिकेट थिंग्स। So, as you are going from deep to shallow region, your wavelength is decreasing. Perfect. Like this. इस तरह थोड़ा सा इसको साइड पे कर देता, like this. Perfect. Obviously, you can continue forward, but the main purpose is done. You are showing that the wavelength is decreasing. You have marked the boundary. You have labeled the deep and shallow region. Now, most of you wouldn't believe me कि सर ये डायग्राम एक्सेप्टेबल है। तो चलो मैं आपको मार्किंग स्कीम ही दिखा देता हूं, मुझ पे बिलीव ना करो बेटा, ना करो। Diagram shown within the ripple tank. Crest parallel to the bar hitting the boundary with a boundary labeled. So there is a mark for the boundary label. Now see this. No direction change if the crest are initially parallel to the boundary with a wavelength change only. बेटा अगर आप क्रेस्ट पैरेलल टू द बाउंड्री बना देते हो तो सिर्फ आप वेवलेंथ चेंज करके ये मार्क्स ऑब्टेन कर लोगे। Different wavelength shown before and after refraction and constant before and after. सिंपल। कांस्टेंट बिफोर एंड आफ्टर का मतलब क्या है? कांस्टेंट बिफोर एंड आफ्टर का मतलब ये है बेटा कि ये वाली वेवलेंथ एंड ये वाली वेवलेंथ जो है वो सेम होनी चाहिए। सिमिलरली ये डिस्टेंस एंड ये डिस्टेंस और मे बी एनी डिस्टेंस बिटवीन द टू वेव फ्रंट्स आफ्टर रिफ्रैक्शन शुड बी सेम। बेटा ये इतनी इजी डायग्राम है, आपको कोई इंक्लाइन नहीं बनाना, कोई स्लांटेड चीज़ें नहीं बनानी, सिंपल रखो काम को एंड यू विल सक्सीड इंशाल्लाह। अच्छा, लेट्स सी दिस figure 8.4. Okay, so we have figure 8.4 shows a connection to the internet made from a remote station. Perfect. A, perfect, using a satellite above the earth's surface. Perfect. Data is sent between station A and B using microwaves. Perfect, using microwaves which travel to and from the satellite. Station B is connected directly to the internet using optical fibers. Perfect. The speed of the microwaves is this. Station A and B are each 560 kilometer from the satellite. Okay, so this is also 560 kilometer and this is also 560 kilometer. Perfect. State the time taken for the data to travel from A to B using microwaves. बेटा टोटल डिस्टेंस क्या हो जाएगा? टोटल डिस्टेंस क्या हो जाएगा? 560 प्लस 560 विल बी इक्वल टू व्हाट? 1120 किलोमीटर। बेटा टोटल डिस्टेंस ट्रैवल्ड बाय द माइक्रोवेव क्या हो जाएगा? 560 इंटू 560 दैट इज 1120 किलोमीटर। परफेक्ट। स्पीड, स्पीड ऑफ माइक्रोवेव्स क्या है? What is the speed of microwaves? 3 into 10 raised to the power of 8 ms minus 1. Can you calculate the time? Yeah. Distance over the speed. Distance क्या है बेटा? 1120 into 10 raised to the power of 3 divided by the speed, that is 3 into 10 raised to the power of 8. टाइम किसके इक्वल आ जाएगा बेटा? टाइम कम्स आउट टू बी 0.0037, 0.0037 सेकेंड। फिर the same data can be sent from A to B in a shorter time along the surface of the earth. Perfect. Using infrared waves to carry the information in optical fibers. Perfect. State one property that infrareds and microwave have in common. Both are electromagnetic waves. Both are part of electromagnetic spectrum. ये लिख दो. Both are part of electromagnetic spectrum. Both are part of electromagnetic spectrum. Perfect. Both are part of electromagnetic spectrum. Simple. Nothing complicated here. State one other advantage of using optical fibers. बेटा ऑप्टिकल फाइबर्स यूज करने का एक और एडवांटेज क्या है? You have greater amount of security. Optical fibers provide greater security. Simple. Greater security. Let's further move ahead. Let's move on to the next question. Thorium-229 is a radioactive isotope used in several medical applications that involve alpha particles and beta particles. Perfect. During ionization, a helium atom becomes a helium ion. बेटा ड्यूरिंग आयोनाइजेशन क्या हो रहा है? एक हीलियम एटम एक हीलियम आयन में कन्वर्ट हो रहा है। परफेक्ट। फिगर 9.1 shows a diagram of helium plus ion. Perfect. You have this helium plus ion. State how the structure of a helium atom differs from the structure of an helium ion. बेटा हीलियम आयन में क्या होगा? हीलियम आयन में सिंस यू हैव अ पॉजिटिव चार्ज व्हाट विल हैपन? हीलियम आयन में व्हाट विल हैपन? Helium ion में you will have one electron and two protons, or you can further say helium ion has one less electron compared to the helium atom. Compared to the helium atom. Compared to the helium atom. Perfect. State how the structure of an alpha particle differs from the structure of a helium ion. बेटा हीलियम आयन में यू हैव इलेक्ट्रॉन, अल्फा पार्टिकल में यू हैव नो इलेक्ट्रॉन्स. यू कैन राइट इट हियर. यू कैन से हीलियम आयन, हीलियम आयन has a electron, has an electron. However, alpha particles have no electron. However, alpha particles have no electrons. Simple. आगे बढ़ते हैं बेटा. A nucleus of thorium 229 decays by alpha emission to a nucleus of element X. Perfect. Alpha emission हो रही है. Perfect. The nucleus of X then decays by beta emission. Perfect. Complete table 9.1 to show the number of protons and neutron in a nucleus of X and in a nucleus of Y. Perfect. बेटा जब आपकी alpha particle decay हो रही है, what will happen? Proton number will decrease by 4. This will become 86. Mass number will decrease by what? Sorry, my bad. Whenever you are having an alpha particle decay, your proton number decreases by 2. This will become 88. And your mass number decreases by 4. This becomes 2, 2, 5. Perfect. So, what are the number of protons in X? Number of protons in X is 88. What are the number of neutrons in X? Very, very easy. 225 minus 88. The number of neutrons in X comes out to be what? 225 minus 88. This comes out to be 137. Perfect. Let's move on to Y. If this is 225, 88, you are having a beta emission, what will happen? Mass number remains unchanged. Proton number increases by 1. So the number of protons in Y is 89. What is the mass number? 225 minus 89. This becomes what? 225 minus 89. This becomes 136. Perfect. You can obviously remove the calculations and only write 136 and 137. That will also make complete sense. ठीक है, चलो आगे बढ़ते हैं बेटा. Experiments can show that a sample of a material is radioactive. Perfect. Describe the apparatus and the procedure used to show that a sample emits both alpha and beta particles. You may draw a diagram of the apparatus if you wish. Whenever the examiner tells you to draw a diagram, you draw a diagram, you respect the examiner. First of all, you will make a lead box like this is your lead box. Then you will make your radioactive source like this. This is your radioactive source. Let's label it radioactive source. Perfect. And this is your lead box. Perfect. And what else will you make here? You will make a GM tube like this. This is your GM tube. It will be attached to a counter like this. It will be attached to a counter like this. Perfect. Now, how can you detect that an source emits both alpha and beta particles? Beta, how are you going to detect that this source emits alpha and beta particles? What will you do? You will first of all place a paper here. You will first of all, or even doing that, you will notice the initial count rate. Let's say it is 800. Then you will place a paper here. If you place a paper and the count rate drops 800 से let's say 600 हो गया, then alpha are present. बेटा फिर आप क्या करोगे? फिर आप एक एल्युमिनियम की शीट यहां पे प्लेस करोगे. If the count rate further drops, let's say it goes from 600 to 400, it indicates that beta particles are also present. Let's write all of this down. Let's write all of this down, and let's just leave this with a paper or aluminum, and let's give a random count rate here, 800. Perfect. So what will you say? Place the source, place the radioactive source in front of a GM tube and counter. Place the radioactive source in front of a GM tube and counter. Perfect. फिर क्या करोगे बेटा? Place a paper between the radioactive source and GM tube, between the radioactive source and GM tube. Perfect. If the reading decreases, if the reading decreases, if the reading decreases, what will happen? If the reading decreases, alpha particles are present. If the, or a better way to say it would be, if the count rate decreases, if the count rate decreases, alpha particles are present. Alpha particles are present. Perfect. फिर क्या कहोगे बेटा? Now place an aluminum sheet. Place an aluminum sheet between the radioactive source, between the radioactive source and GM tube, If the reading further decreases, beta particles are present as well. If the reading further decreases, let's write it completely. Beta particles are also present. Beta particles are also present. Perfect. Let's further move ahead. State what is meant by half-life of thorium 229. What is meant by half-life of thorium 229? Time taken for the number of nucleuses to half. Time taken for the number of nucleuses to half. You can write here. Time taken for number of nucleuses to half. Number of nucleuses to half. Simple. Nuclei to half. Simple. Let's further move ahead. A sample of pure thorium contains 4 into 10 raised to the power of 14 atoms. After 22,000 years, the number of thorium 229 in the sample is this 5 into 10 raised to the power of 13. Determine the half-life of thorium 229. Beta, half-life किस तरह determine करोगे? Okay. Let's start the machine. 4 into 10 raised to the power of 14 atoms थे आपके पास initially. After one half-life, बेटा कितने atoms हो जाएंगे? 2 into 10 raised to the power of 14. After another half-life, कितने atoms हो जाएंगे? 1 into 10 raised to the power of 14. After another half-life, कितने atoms हो जाएंगे? 0.5 into 10 raised to the power of 14. That is equals to 5 into 10 raised to the power of 13. So how many half-lives do we have? 1, 2, and 3. 3 half-lives are getting covered in how many years? 3 half-lives are equal to how many years? 22,000 years. 22,000 years. Beta, 1 half-life कितने years के equal होगी? Let's place x here. X is equals to 22,000 divided by 3. Your answer of half-life comes out to be 7,300 years. This marks the end of this paper. If you have any questions, you can ask in the comments below.